Let us briefly introduce ourselves to acids and bases. A very simple definition for acids is that acids are ionic compounds that will give you hydrogen ion as a cation when they are dissolved in aqueous solutions. Let us take a look at an example. Hydrochloric acid, HCl. When you dissolve hydrochloric acid in water, it will dissociate to give hydrogen ions and chloride ions, which means it is behaving like an ionic compound. And it is giving us hydrogen ions in aqueous solutions. Anytime you see hydrogen ions, as written here in aqueous solutions, you know you are dealing with an acid. Let us briefly take a look at some properties of acids. Acids have a sour taste. That is why when you bite an unripe fruit, you would spit it out because of the sour taste. And they can dissolve some metals because they are corrosive. We will learn a lot more about acids and bases in later chapters. A very simple definition for bases is that bases are ionic compounds that will dissolve in aqueous solution to give us hydroxide ion. Let us take a look at an example. Sodium hydroxide. When you dissolve sodium hydroxide in water, it will dissociate to give sodium ions and hydroxide ions. The fact that it gives us hydroxide ions in aqueous solution is why it is known as a base. Let us take a look at some properties of bases. Bases have a bitter taste, and you must have had an experience with this if you've ever tasted a soap. And bases are slippery when you touch them, which is actually the reason we use them as soaps. They can easily wash off because they are very slippery. These are some examples of common acids and bases. Hydrochloric acid, hydrobromic acid, nitric acid, sulfuric acid, perchloric acid, acetic acid. These are very common acids. Common bases are sodium hydroxide, lithium hydroxide, potassium hydroxide, calcium hydroxide, and barium hydroxide. And all of these bases are soluble in water. They will dissociate in water to give the metal ion, and they all will give you OH minus hydroxide ions when you dissolve them in water. If you react an acid with a base, they will neutralize each other, which is why the reaction is called neutralization reactions. This is the general form of acid-base reactions. When you react an acid with a base, you will end up with water which is neutral, and an ionic compound that we simply call a salt. In general, we call all ionic compounds salts. Let us take a look at an example of acid-base reaction that will give us salt and water. If you react sodium hydroxide, which is a base, with hydrochloric acid, which obviously is an acid, a double displacement reaction will occur. Again, this is a double displacement reaction. So let us write the product. We will get sodium chloride, which is an ionic compound that we can simply call a salt. And we will get H2O, which is liquid water. Because we produce a neutral compound as one of the products, that is why these reactions are called neutralization reactions. The acid and the base essentially will neutralize each other. Let us take a look at an example of neutralization reactions in full. Write balanced molecular, total ionic, and net ionic equations for the reaction between nitric acid and calcium hydroxide. Nitric acid is HNO3, dissolved in aqueous solution. Calcium hydroxide is CaOH parenthesis 2, which is also soluble in water. When you react these two together, a double displacement reaction will take place. Nitric acid would split apart into H plus and NO3 minus in aqueous solution. Calcium hydroxide will split apart into Ca2 plus OH minus in aqueous solution. If you're asking why is calcium plus 2, calcium is from group 2A. If a double displacement reaction takes place, the positively charged ion on the first compound will combine with the negatively charged ion in the second compound. So that is going to give us HOH, which is another way of saying H2O. Also, the anion in the first compound will combine with the cation in the second compound, and in this case it's going to give us calcium nitrate, which will be soluble in aqueous solution. We can balance this equation if we place a 2 as the coefficient of nitric acid. We now have 2 nitrates on the reactant side and 2 nitrates on the product side. All we need to do to balance the equation now is to place a 2 as the coefficient of water. Now, if you look at the number of hydrogen atoms on the product side, it will be equal to the number of hydrogen atoms on the reactant side, which is 4 on each side. But the equation we just wrote out is the molecular equation. Let us now take a look at the total ionic equation. Nitric acid will behave as an ionic compound it will give us hydrogen ions and nitrate ions. Each of them would have coefficient of 2 because of the 2 here in the balanced equation. Calcium hydroxide will split apart into calcium ions and 2 of hydroxide ions. H2O is a liquid. It will not split apart because it is not ionic. So it's just going to remain H2O and the coefficient is 2. Calcium nitrate is an ionic compound. It will split apart because it is soluble to form calcium ions and 2 nitrate ions. That is the total ionic equation. Let us now write the net ionic equation. Before we can write the net ionic equation, we need to take out the spectator ions, which means the ions that occur on both sides of the equation. On both sides, we have nitrate. That means nitrate is a spectator ion. And on both sides, we have calcium ions. That means calcium ions are spectator ions. If we take these 2 spectator ions out, we will be left with 2 hydrogen ions plus 2 hydroxide ions, which will give us 2 H2O. But if you look at all of the coefficients, they are all divisible by 2. We always want to use the lowest possible factors in the coefficients. So if you divide all the coefficients by 2, you will end up with hydrogen ions plus hydroxide ions giving H2O liquid. This is the net ionic equation, which is essentially what we call the neutralization equation. Because if you interpret this equation properly, hydrogen ion, which represents the acids, is combining with hydroxide ions, which is representing the base, to give us water, which is neutral. So the acid and the base are neutralizing each other to give us a neutral water molecule.